In this problem, we are going to take a look at how to cube a binomial. Specifically, we are asked to perform the operation and simplify 2t plus 3 to the third power. Now, there are several ways to look at this problem. One way is to actually go back to the definition of exponents. So let's start there. The quantity 2t plus 3 to the third power is really saying I have a base, 2t plus 3, being raised to an exponent of 3. Now the key here is that the base itself is a binomial. It's two terms. So when we have a base that is not a monomial, we have to be very careful applying the exponent to it. Let's take a look by expanding what this is saying. This is saying I have the base of 2t plus 3, and I'm going to multiply it times itself 3 times. And again, the key here is that I have two terms. I have a binomial as my base. So I can't just apply that exponent to each of the inner terms. Why? Because of distribution. There's some extra factors that come into play. Once it's expanded, how do I multiply? Well, I begin by starting with two factors and multiplying those. So let's just take a look at the first two factors, 2t plus 3 times 2t plus 3, and let's zone in and focus on those. We'll begin by multiplying those through. I can either recognize that that is a binomial square, or I can simply FOIL. That is, let's take the first term 2t and multiply it times 2t, and then 2t and multiply it times 3. Then I will take 3 and multiply it times 2t, and then I'll take 3 times 3. Some people call this the FOIL method or the distribution property. So let's write down what we get when we FOIL or distribute. 2t times 2t gives us 4t to the second, plus 2t times 3 gives us 6t, plus 3 times 2t gives us 6t, and then 3 plus 3 times 3 gives us 9. So really, when we expand 2t times 2t plus 3 times 2t plus 3, we get 4t squared plus 6t plus 6t plus 9, or simplified, that is 4t to the second power plus 12t plus 9 times the quantity 2t plus 3. Phew! All right, well, we're almost done. What are we left with? We're now left with a trinomial times a binomial. The pluses in between separate and make terms, so we have to again apply a distribution property to multiply these polynomials. We're going to start with 4t squared and we're going to multiply that through. We're going to take 4t squared times 2t and 4t squared times 3. And when we do so, that's going to give us 8t to the third power plus 12t to the second power. We're going to keep going. We're now going to take the middle term, 12t, and we're going to multiply that times the second quantity. So we're going to take 12t times 2t and 12t times 3, and that's going to give us plus 24t plus 24t squared, sorry about that, plus 36t. And then finally, we're going to take that last term in the first trinomial, 9, and we're going to multiply that times the binomial 2t plus 3. So 9 is going to get multiplied by 2t, and 9 is going to get multiplied by 3. And that's going to give us plus 18t plus 27. We've finished distributing. Our last step now is to combine like terms. So put things together that have like exponents. We have 8t to the third, and then we're going to combine the two like terms, 12t to the second plus 24t to the second, and that's going to give us 36t to the second. And then we're going to put together the like terms 36t and 18t. And that's going to give us plus 54t, finally plus 27. Nothing else can be combined. Our answer is simplified. That means that 2t plus 3 raised to the third power is actually expanded out to be 8t to the third plus 36t squared plus 54t plus 27. I hope this makes sense.